Okay, this is topic 2 of our physics unit. It's on the laws of motion. It says, net force. An object in motion has many forces acting upon it. When a vehicle is braking, for example, there are 3 different forces that cause the vehicle to slow down. The force of air resistance, the force of friction between the tires and the road, and the force applied by the braking system. If these forces overcome the force that is propelling the vehicle forward, then the vehicle will eventually come to a stop. The sum of these forces is called the net force. So what it's talking about is if we are going in this direction, there's a couple forces that are acting basically backwards on it, and that's the force of friction, which is helping us lose speed, I guess, as we go down the road. The force of air resistance, so the resistance of the air that's pushing back at us, and the force of the braking system. So if you have a brakes, well, hopefully you do in your vehicle, those are acting upon your vehicle to stop you or push you back in the other direction of the way you're traveling. The effect of mass. So it says one more factor that affects the rate of deceleration of a braking vehicle is the mass of the vehicle. Objects with a greater mass have a more difficult time overcoming the forces that propel the vehicle forward, and will thus require longer to come to a stop due to the decreased rate of deceleration. The same applies to vehicles moving forward. If the same force is applied to 2 objects, the object with the smaller mass will accelerate at a greater rate than the object with a larger mass. So what it's saying here is that mass has an effect on basically your acceleration. So it says, vehicles moving forward in the same force is applied, something smaller will accelerate faster. And you've probably seen this on the road. I notice it when I'm driving. If I'm coming up to a stoplight and then I'm going to be behind a bigger vehicle, I'll normally try and pull to the lane that they're not in, because once the light turns green, it's going to take them a lot longer to accelerate than me in a smaller vehicle, just because there's a greater force basically, or there's a greater need for gas or that force propelling them forward to be able to move them at the same speed as me, for instance. If you've drove before and you notice driving in like a car versus a truck, there's definitely a difference in your acceleration. So Newton's second law of motion says that this relationship between net force, mass, and acceleration is defined by this law, which states that an object will accelerate in the direction of the net force acting upon it. So if we're pushing behind something, it's greater than the forces that are pushing against it, then it's going to move in the direction that we're pushing it. So whatever direction has the greatest force, the greatest net force, that is the direction that our object is going to move. The law is represented by this equation. And note that because force may be calculated by multiplying mass in kilograms by acceleration in meters per second squared, the correct unit for force is kilograms times meters per second squared, or we can just change that to N. So whenever we have all of this kilograms times meters per second squared, we can also write at just as N. And N stands for newtons. Newtons is a way that we measure force in physics. Okay? So let's try an example of this. I'm just going to, at the very top of this slide, going to write down the formula that it gives us, just so that we can remember it when we're doing these questions. So we got that, or we got F net is equal to M times A. So let's try these questions. So it says a vehicle has a mass of 1,250 kilograms. So right as I'm reading this, I'm always writing down the pieces of information they give us. It's a mass. I don't know why it's disappearing. Okay. So we've got that, and it's traveling at a rate of 45 kilometers per hour. So that is a velocity. That's not in our question. I'm going to just keep reading. When the driver engages the brake to stop at an intersection, if the net force on the vehicle is 7,000 newtons west, so it's giving us a force. And west we know as being a negative. Determine the magnitude and the direction of the vehicle's deceleration while the net force is applied. So we're looking for deceleration, or A. Okay? So they have added that extra piece in there that actually is a velocity. We don't have velocity in our question, so we would not write it. So we're looking for A, and if we look at the two formulas that we have up here, this one is the one that A is equal to. So that's the one we're going to use because that's the one that we're solving for A in this example. So we got A is equal to force net divided by our mass. And we can plug in our pieces. So our force is 7,000 newtons. And it's over our mass, which is 1250 kilograms. And if we do that out on our calculator, just got to turn on my calculator. We get an answer of 5.6. Don't got a lot of room here. So that's 5.6. And our units for this, it is acceleration. So our units for acceleration, if you don't remember, we can go back to over here. It says that our units for acceleration are meters per second squared. So that's what we're going to write here. So meters per second squared. Okay? So that is our, that is our answer to that example. I'm just trying to circle the answer. So 5.6 meters per second squared. And then it says, determine the length of time this net force must be applied in order for the vehicle to stop. Wow, so this is using some information that we did in topic 1 that is looking at our stop times. So just to refresh us on that, I'm going to go back to topic 1 so that we can look at the formula we're going to need to use here. On your Google Classroom, I'll post or I'll update the formula sheet so that you can see these physics things also on there when you're going about doing the questions for topic 2. So it's near the end of this section. Looking at stopping. So, in step 2 here, if you zoom in here, it says, first use the rate of deceleration given to calculate the time required to stop. So our formula for time required to stop is T is equal to VF minus VI divided by A. So if I go over here, T is equal to VF minus VI all divided by A. divided by A. Okay, so we can use this formula to figure out the time that it took us to stop. And that's when this will come into play. So we didn't need it in part A, but we do need that velocity in part B. So it says that the vehicle's traveling at 45 kilometers an hour. Something that's major here is that our acceleration is in meters per second. This is in kilometers per hour. So we're going to need to convert it. Okay. I'm going to do that on a separate note, just so that we have enough space, or I'll do it right here, just outside of here. Okay, so we have got 45 kilometers per hour, and we need to change that into meters per second. So if we have kilometers on the top, we put kilometers on the bottom. If we've got hours on the bottom, we put hours on the top. These are just ones. And then for our conversion, we need to put our kilometers into meters and our hours into seconds. We basically need to write down how many meters are in 1 kilometer, and that's 1,000. And how many seconds are in 1 hour, and that's 3,600. This is something we have gone over before, so it's not totally something new. So if we use our calculator, we go 45 multiplied by 1,000, and then we divide by 3,600, and I got 12.5. Okay, so that's 12.5 meters per second. Oops. So if I go back into here, I can solve for my time. So our time is what we don't know. We need VF, VI, oops, going off the bottom there, VI, and our acceleration, right? So our acceleration we figured out in the last question to be 5.6. So I'm going to put that right here. For our velocity initial versus our final velocity for stopping should be 0. And our initial is what we just figured out in the last question to be 12.5. Not the last question, but we converted our 45 kilometers an hour to meters per second. And now we can solve this or put it into our formula. So going back to red, our time is going to be our velocity final, which we got as being 0, minus our velocity initial, which is 12.5. One thing I need to check, it says we're going 12.5 east. We know that 12.5 east is a positive number, so it doesn't really affect this question. We don't really need to put the positive in there, but I'm just showing you how you would put that into your calculator. And then on the bottom we have 5.6 meters per second squared. Okay, so if we calculate that all out, we take 0 minus 12.5, so I get negative 12.5, and then divided by 5.6, I get negative 2.23, and there's something wrong here, so this would be seconds because this is a time. We can't have negative time. So what I've got to double check is, did I put units with this? So my acceleration was a deceleration. So when you're decelerating, that should be a negative. So that is my mistake. You can't have negative time. So that should be negative 5.6. So if I do that into my question, negative divided by a negative will give you a positive So that is 2.23 seconds, okay? So if you get a negative time, you've done something wrong, right? So that is the answer, so 2.23 seconds, all right? So that's how you would do that type of example. Here's another example. So it says the engine of a motorcycle supplies a force of 1880 newtons west. So as I read through the question, I always like to write down what I've got. That is a force, 1880 newtons. To overcome frictional, sorry, I need to put the west there too. So negative is west. I'm just going to erase this just because I didn't leave enough room. So we've got a force of negative 1880 newtons. To overcome friction, which is another force of 520 newtons east. So that's positive. Okay. The motorcycle and rider have a combined mass, so it's giving us a mass of 245 kilograms. Determine the motorcycle's acceleration. So A is what we are looking for. So something that is really important when you're doing these questions, if they give you more than one force, to find your force net or F net, you just add your forces together. So our F net here, we're going to add negative 1880 plus our positive 520. Okay, so if we do that, I can put that into, even if you're using an iPhone, 1880, right beside the C button, there's a little plus minus. You can put that in and then go plus 520. And my net force that I got was negative 1360 newtons. Okay, so now I can plug that back into my formula that I had up here. F net is equal to m over a, or a is equal to F net m. In this case, we're looking for acceleration, so I'm going to use the formula a is equal to F net multiplied by m. So in this case, we are going to take our F net, which we found out to be negative 1360 newtons, multiplied by our mass, which we found out to be 245 kgs. All right, so if we do that out in our calculator, I got an answer of negative 333,200. That's an acceleration, so it should be in meters per second squared. Sorry, I'm got so much stuff written here. I'm going to erase some just temporarily. Well, I guess hopefully you've already got this stuff written down, but I just want to give enough space for this answer. So 333,200, and that is in meters per second squared. Okay? So let's put a box around that. And that is our answer to that question. The next question says a car with a mass. So this is a totally different question. A car with a mass. So as I'm reading through the question, write down the things that they give us. Is traveling on a highway. The engine of the car supplies a force of, so I'm just going to write force of 4,800 newtons, and that's west, so that's negative. To overcome a frictional force, so another force, I'm just going to add them because it's another force, is 4,800 newtons west. So that's a positive 4,800 newtons. Determine the car's acceleration. Okay, so again, we're using A is equal to F times M. Our acceleration is going to be our force, which is 4,800 plus or minus 4,800 basically. So if we do that, it would be 0. Multiplied by our mass of 1075. Hopefully you already know that anything times 0 is 0. So our acceleration is 0 meters per second squared. Okay. So the forces, or the F net, is basically equal to 0 because there's the same force acting on each side of it, which means it's not accelerating. Okay. So it's going at a constant speed. The next one, it says Newton's first law of motion. So in the absence of a net force, such as demonstrated by the practice problems on the previous slide, an object in motion will maintain its velocity, and an object at rest will remain at rest. So this is the classic, an object in motion stays in motion. So if there's no forces acting on, or the net force is equal to 0, then an object in motion should stay in motion. We know in life that, like, if you're driving in a car and you stop your foot on the gas, eventually you're going to come to a stop. And that's due to the fact that there's lots of forces that are slowing you down or acting against you, like friction and air resistance. But in theory, if we didn't have any of those forces, then we should stay in motion. Okay? So this is referred to as Newton's first law of motion, and Newton's first law explains why a space probe with no crew, such as the Voyager 2, requires no engines to travel beyond the solar system. In deep space, there's no friction to slow things down, so the probe simply maintains its initial velocity. So yeah, in space, in a vacuum, in something that isn't going to have any sort of air resistance or friction, then you're going to have something stay in motion. Inertia, this is like, I always think of this in a car. It says Newton's first law also explains why an object tends to resist changes in motion, a property referred to as inertia. The greater the mass of an object, the more difficult it will be to change the motion of that object, and therefore the greater its inertia. Many of the safety features in your vehicle are actually designed to prevent the injuries caused by inertia during an accident. So what is inertia? Does it not explain it? It gives you a video. Well, I'll explain it to you right now. So inertia is basically when you are driving along, you're going forward, right? And then all of a sudden, maybe someone slams on the brakes. So your body, because it hasn't changed motion, it's still going to be going forward like your car would have been. So this is why you have a seatbelt. Because if you didn't have a seatbelt, well, if someone slams on a brake, your body just keeps going forward, your car stops, and then you fly through the windshield. So inertia is when an object in motion stays in motion. And then the bigger the thing, the harder it is to slow it down, basically. And that's what inertia is. So I'm just going to say object an object in motion stays in motion when direction of force changes suddenly. This is why if you have a crazy driver, they might not give enough time to slow down before a turn or something, and your body's going to be flinging in all different directions just because you need more time for your body to be able to change direction. And if you don't give that time, that slowing down, that sort of slower change, then your body is gonna keep moving. Okay? So that is that section. It's not too much to remember. You just need to look at this one formula, which is from the second law of motion that Newton came up with, which is F net is equal to ma, or A is equal to F net over m. This is just a changing the way that the formula is written. Either one will get you the same results. It's all of the same theory. All right, so I'll add that to your formula sheet on the Google Classroom, and that is all of topic 2. So please go to your topic 2 work, if I can get there. So for your topic 2, you have some practice problems that go along with the Newton stuff. Maybe. Doesn't seem like it wants to let me, but you want to do those practice problems, and then there should be a Unit 2 review questions as well. It looks like we've got some Unit 2 review. My unit, I don't know, this is in dark mode, whatever. So you've got some Unit 2 questions that you need to do as well, and then that'll finish up the physics unit. We are going to do I'll probably post a quiz for you on, or a chapter test on this by the end of the week. So please get on that, because tomorrow I will probably start on the 3rd unit. We don't have a lot of time left, so we need to continue going. So it's your responsibility to get this work done and stay on top of things. Let me know if you need any help with